You ever look at a massive skyscraper or a huge dam and just wonder what's holding it all up? I mean, it's not just the concrete and steel you can see. There's this whole hidden science at work, deep beneath the surface. Today, we're going to dig into that. It's called engineering geology, and it's pretty much the unsung hero of our modern world.
Okay, so let's start with a question that, let's be honest, has probably crossed your mind. Maybe it's even freaked you out a little. You see a crack in a wall and you start thinking, wait, why is that happening? Why do these buildings, which seem so incredibly solid, sometimes crack or shift?
Well, here's the thing. The answer isn't always in the building itself. To find the real reason, you've got to look down. The answer is, quite literally, beneath the surface, in the very ground that building is standing on. And getting to know that ground, that's really the first step in what we call the science of foundations. And trust me, it's about a whole lot more than just pouring concrete. It's about understanding the earth itself.
This whole specialized field has a name: engineering geology. Think of it as the crucial link between the science of our planet and the nuts and bolts of civil engineering. Its entire job is to make sure our dams, our bridges, our tunnels, all of it, are safe, stable, and built to last, without, breaking the bank.
And right at the heart of it all is the soil. This stuff is the literal foundation for everything we build. But here is the most important part. Not all soil is created equal, not even close. So soils basically fall into two big families. First up, you've got your residual soils. Think of them as the home bodies. They're formed right there in place as the rock underneath them breaks down over time. Their grains are all sharp and angular. And then you've got the world travelers, transported soils. These guys have been carried all over by wind, water, or glaciers. And that long journey, it tumbles them around, smoothing their grains, making them rounded. Now that might sound like a tiny detail, but it is absolutely critical. See, those sharp, angular grains lock together really tightly under pressure, which makes for a super strong foundation. The rounded ones, they can shift and slide around. Big difference. Okay, so knowing that difference is just the beginning, and figuring it all out is the job of a very specific expert, the engineering geologist. So let's take a look at what they actually do on a project. You can think of them as the project's foundation scout. I mean, before anyone else is even on site, they're out there finding the absolute best spot to build. They're testing the soil's strength, checking how stable all the different layers are, and they're even finding the best nearby rock and sand to use for the concrete. All of that intelligence gets put into these super detailed geological maps that guide, well, pretty much every single decision that comes after. Yeah, I like to think of them as detectives. They're gathering clues from the earth, from the shape of the land, the type of soil, where the water is, to solve this really complex puzzle. And the whole point is to solve it before a single shovel even hits the ground. It's all about preventing problems before they can ever happen. All right, so if the clues are all hidden underground, how do these detectives actually see what's down there? Let's get into the tools of the trade. I mean, this is the fundamental question for any project, right? You can't just guess what's under your feet when you're about to put a 50-story building on top of it. So how do we get a clear picture? Geologists actually have a few key ways to see underground. They can dig shallow test pits to get a direct look, or drill these really deep boreholes to pull up samples from way down. For a broader picture without all the digging, they use something called geophysical methods, basically sending sound waves or electrical currents into the earth to map out the layers. And finally, they do what are called in situ tests, which just means testing the soil right there, in its natural home, to see how it really behaves under pressure. But by far the most common, the most versatile tool for this detective work is a very specific kind of drill, the continuous flight auger. The way it works is actually brilliantly simple. So, there's a cutting head at the tip that just breaks up the ground. Then, this long continuous spiral blade, it looks kind of like a giant screw, carries all that soil up to the surface. From there, geologists can just grab samples from different depths and take them back to the lab for testing. Easy. So why is this the go-to method? Well, it's incredibly versatile. It works in pretty much any kind of soil you can think of, from soft clays to really dense sands. It can drill super deep if you need it to, like up to 100 meters. And maybe most importantly, it's fast and it's cost-effective, which is just essential for keeping these huge projects on schedule and on budget. Okay, so we've drilled down, we've collected our samples. Now for the important part. Let's see how all this investigation work translates directly into building a safe, stable structure. This data, it isn't just a report that sits on a desk. It's basically the blueprint for the foundation itself. It tells engineers exactly what they're dealing with, the different layers of soil, where the groundwater is, any hidden dangers like unstable slopes. It tells them how the ground is going to react when you put this massive weight on top of it. In short, it dictates exactly how that building needs to be designed to connect safely with the earth.
Now, you're probably thinking, wow, this sounds really extensive. All this drilling and testing, doesn't that just add a huge cost to the project? And you know what? That's a fair question.
But here's the answer, and it might surprise you. All of this critical work, the whole geotechnical investigation, typically costs between just 0.5% to 1% of the total project budget. Which means it's not really a cost at all. It's an investment. That tiny fraction of the budget is what guarantees the safety and the long life of the entire structure. Think about it. It's like the cheapest, most effective insurance policy you could ever buy for a billion-dollar project.
At the end of the day, it all comes down to a single mission, and this quote captures it perfectly. The goal is to give engineers the information they need to create foundations that are perfectly integrated with the ground they're on, making them safe, secure, and affordable.
And that brings us right back to where we started. That crack in the wall? Yeah, a lot of the time, it's not just a sign of a construction mistake. It's a sign of a geology problem that wasn't properly understood. It's this perfect reminder that everything happening above the ground depends completely on what's happening below it.
So, the next time you walk into some towering building or drive across a long bridge, just take a second. Yeah, the visible engineering is incredible, but it's the invisible science of geology, deep underground, that's truly holding it all up. Kind of makes you think a little differently about what's right under your feet, doesn't it?